In this session, we will discuss about natural response. See, if we have a circuit and we are giving an input to that circuit. So, the input, we can say that instead of input, we can use a term excitation. Okay, so if you are referring a circuit, then the excitation to the circuit means the input to that circuit. And the response means that the corresponding output is called response. See, if we are giving an excitation to a circuit, then the corresponding output is called the response of that circuit. See, if we are making circuits with a resistor, capacitor, etc., and if we are giving an input or excitation to that circuit, that may be a voltage or current or step excitation or a ramp excitation. Like that, we can give different inputs. So if we are giving such excitations, then we can see that there will be a current or there will be some voltage across different circuit elements, and those values of output or those values of voltage or current are called response. So here we will discuss about natural response. See, when we are considering a circuit that containing storage elements such as inductor or capacitor, and these storage elements are independent of sources, that means if a circuit contains inductor and capacitor, and similarly it also contains different independent sources such as voltage sources or current sources, then the response of that circuit depends upon the nature of the circuit. So such type of response is called a natural response. If a circuit containing different storage elements such as inductor and capacitor, also it contains different independent sources such as voltage or current sources, then the corresponding response for a particular input depends upon the nature of that circuit. So such type of response is called a natural response. In another case, if a network contains energy storage elements such as inductor or capacitor, and if we are applying an excitation, that means if we are applying a input or if we are applying an excitation, then with the change in the excitation, the current and voltages changes from one state to another. So that means there is a changes in the response with time, and these responses will be getting to saturated values, will be going to a saturate value after some time, and this response is called a transient response. So in a network containing energy storage elements, and if we are if there is a change in the excitation, then the currents and voltages in that circuit will changes from one state to another, and that means that the response changes with time, and these responses will get a saturated value after some time, and such type of response is called a transient response. And usually we will refer the transient response in the case of circuit containing inductor or capacitor, because it has an ability to store charge, and due to that charge there will be some changes in the output. So these responses will be referring to as a transient response. And if we are considering circuits and that contains some sources such as voltage or independent sources such as voltage or current sources, then the response depends upon the nature of the source or sources, and this type of response is called forced response. So if we are giving an independent voltage source or current source, in the case of a circuit, if you are connecting an independent voltage or current sources, then the response corresponding to that circuit or corresponding to that sources will be called forced response. So if we are applying an external input, and the corresponding response is called forced response, and transient response is due to the energy storage element present in the circuit, so it will give transient responses, and both of the transient response and forced response are together called natural response. So next we will consider a problem. Find the natural response of the RC circuit. See, here an RC circuit is given, you can see here. See here there is a capacitor C and resistance R will be there. There is no external source connected to this circuit. So we are asked to find the natural response of this RC circuit. So here the natural response means that here there is no input, and here the circuit containing the energy storage element capacitor C, and we want to find out the response. Here the response means the voltage across the resistor will be the response here. See, V is the response here, that means this will be the output. See, here it is given that V0 is the voltage across capacitor C. That means we know that the capacitor has the ability to store charge in the presence of electric field. So the initial charge present across the capacitor is V0. So due to this V0 there will be a current through this circuit, and due to that current there will be some voltage drop across resistor R, and that voltage is the response here. So you are asked to find out the natural response of the RC circuit. So here the natural response is due to the presence of initial charge stored in the capacitor. Due to this charge there will be a current flowing through this circuit, and due to that current flow there will be some voltage drop across this resistor, and that voltage is the output in this case. So that is the response. So we have to find out the equation for this voltage V. See, you can see that here the capacitor is the energy storing element. So in the case of energy storing element, we know that if we are writing the equation for the voltage or current, we know that there might be differential terms or integral terms. So in order to solve such type of equations or such type of circuits that containing energy storage elements, it is better to use Laplace transforms, because this Laplace transform will convert the differential equation into algebraic equation. So it will be easier for us to solve such type of algebraic equations. So we will use the method of Laplace transform here. So first of all, in order to apply the Laplace transform method, we have to convert this circuit into S-domain circuit. See here there is a capacitor C and a resistor R. We know that how to convert this capacitor into S-domain. We have studied in the previous session that the capacitor can be converted into a S-domain circuit by the series combination of one voltage source and another capacitor, and its capacitance value equal to 1 by SC and voltage value will be equal to V0 by S. So you should know the transformation of a capacitor into S-domain. So this capacitor will be replaced by the series combination of these two, where this represents the constant voltage source and its value is the initial charge V0 divided by S, and this capacitor will be changed to another capacitor which is having the S-domain value 1 by SC. So this is the representation that we have studied in the previous classes. So we can replace this capacitor by this one, and the rest of the circuit will be as same as that of the circuit given in the question. So there will be a resistance R. See, you can see here a switch. This represents a switch. You can see that this switch is open up to t equal to 0. How can you say that this is open? See, here it is given that at t equal to 0 there is a symbol like this with a arrow mark. That means at t equal to 0 this switch will come to this position. From this position to this position, that means at t equal to 0, what is its meaning? At t equal to 0, the switch will come from this position to this position. Once it comes from the upper position to lower position, that means the circuit will be closed. So at t equal to 0, the circuit will be look like this. Okay. So from the capacitor C, the stored charge will goes through this resistor at t equal to 0. Once the switch is closed, the charge will goes through this circuit like this. So there will be a current flow at t equal to 0, and that current will pass through this resistor R, and it will produce a voltage drop V. So here V is the instantaneous value of voltage. Once we are transforming it into the Laplace S-domain circuit, then it will be capital V. That is the Laplace transform of this V. So here is a series circuit. So you can easily solve this circuit by applying the Kirchhoff's current law. Okay. So now it is transformed into S domain. So you can apply the Kirchhoff's current law to this circuit. So you know that the algebraic sum of the voltage will be equal to 0 in the case of Kirchhoff's voltage law. So we can write the equation as, this is the circuit. If we are applying the KVL to the circuit, we will get this is the voltage, that is voltage V0 by S will be equal to, I is the current. So we can write it as current into impedance. That means current is equal to I, impedance is 1 by SC. So that will be I into 1 by SC is another voltage, and that will be added to I into R, where I is the current flowing through it. So the voltage will be I into R. So by applying Kirchhoff's current law, we will get this equation. And in this equation, we know that we can take I outside. So we will get like this, and by solving this, we will get this. So we want first, from this equation, V0 is the initial charge and I is an unknown quantity. So I can be find out from this equation. So by rearranging this equation, we will get I will be equal to V0 into SC divided by S into 1 plus RSC. This is a simple rearrangement of the above equation. So this finally will give C into V0 divided by 1 plus RSC. See, S and S get cancelled and we will get this equation. So this is the equation for I, and here you can see, you can take the RC outside. So you will get you can change this equation in the form of S plus an unknown value. So we will get V0 by R divided by 1 by RC plus SC. Here along with the S there is a term RC. So we are taking this RC outside. So we will get 1 by RC in the first term plus S into, in the outside quantity there will be RC. So and C get cancelled. So we will get V0 by R divided by 1 by RC plus S. So this is the simple mathematical procedure. So we got the value of I. But what is our need is that we want to find out the value V. This is the response. We know that this is the voltage across the resistor R. So the voltage across the resistor will be obtained by applying the simple Ohm's law. Means that voltage will be equal to resistance into current. So we will get voltage will be equal to resistance into current. See here that before that we have to find out the time domain value of I. Here we got the value like this. This is in the S domain value. In order to find the time domain value, what we have to do is, we have to take the inverse Laplace transform of this quantity. So inverse Laplace transform will give the time domain value I of t, and you know that this is the known formula, that is 1 divided by S plus A. See, V0 by R is a constant, so we can take it here V0 by R, and this is in the form of 1 divided by S plus A. What is inverse Laplace transform of 1 divided by S plus A? You know that it is nothing, that is e raised to minus 1 by RC into t. This is the inverse Laplace transform of this form. See here we are taking RC outside in order to make it in a known form. So we can apply inverse Laplace transform easily. So we have to convert this equation in the form of a known formula. That is why we are taking RC outside. So we will get I of t equal to V0 by R into e raised to minus t by RC. This is the inverse Laplace transform. So once we get the value of I of t, we can find out the value of V by Ohm's law. We got the value of I of t like this, that is I is equal to V0 by R into e raised to minus t by RC. So V equal to resistance into current, that means that will be equal to V0 into R, and that will give R and R get cancelled, that will give V0 into e raised to minus t by RC. So voltage will be equal to V0 into e raised to t by RC. So we got the value of natural response C. We are asked to find out the natural response V. So first we are transferring the circuit into S domain, and for that we are converting the capacitor into this form, and then we are applying the Kirchhoff's voltage law, and by applying Kirchhoff's voltage law we will get the value of current. Once we get the value of current, we can find out the voltage value by using the Ohm's law, And before using the Ohm's law, we have to find out the inverse Laplace transform of current. So we will get the time domain value of I. That is the procedure for finding the natural response of RC circuit. Here you can see that there is no other independent sources in this circuit, and here the current flow is due to the stored charge in the capacitor. So that's all about this topic. Thank you.